Alright, what is going on, guys? It's Maps here, and today we'll be wrapping up the rest of laws of integral indices as well as touching scientific notations. So last time we have learned these 3 rules, and well, today I'm going to teach you the rest, which is a 4, 5, and 1 special one. So I'll teach you the special one first. So our special rule today is a to the power of 0 would be equal to 0. Alright, remember this. So 1 to the power of 0 would be equal to 0. Alright, cool? Great. Next thing we have is a to the power of a negative number, where n is positive, alright? So that would be equal to a over, it's a to the power of 1. So just normal a over a n. So, for example, if 1 to the power of negative 3, then that would be equal to 1 over 1 times 3, which would be equal to 1 over 3. Great! So now, with that, we have one final rule of laws of integral indices, which is a m over a n, or a m divided by a n. So for this rule, it's not that hard, but you know, it will be equal to a of m divided by n. So let me just write that better. Wait. So let me put this in a real world example. For example, we have 2 to the power of 5 divided by 2 to the power of 4. Oh, sorry, that's 2 power of 2, alright. So that would be equal to 2 to the power of 5 over 2. Alright, cool. So, now we have finished law of integral indices, and we can move on to scientific notations, which is easy, which is basically expressing numbers, for example 10, into a form of a times 10 to the power of x, where x is a positive or negative integer. It has to be an integer, alright. So, for example, 10, for example, take like this example, 10 would be equal to 1 times 10 to the power of 1, because quick maths. And remember, size multiplication, this number has to be between 1 and 10, alright? Remember. Just remember, it has to be between 1 and 10. It cannot be 1, it cannot be 10. Remember. And as well as this number, remember, don't let it be anything other than 11 or 10. Alright? Cool. So now let's put the real world example. Let's have 250k would be equal to what? That would be equal, just count the zeros. So for a huge number like this, you want to count the zeros. So you have 1, 2, 3, and 4. Just count the zeros and then put this number, a form of 1, between 1 and 10, which would be 2.5. So that would be 2.5 times 10 to the power of 4. Clear? Alright, let's move on to the final thing, which would be scientific notations, but with negative powers. So for example, we have 0.000. There's 30 zeros here. And then we have a 5 right here. So for that, what you want to do is count these zeros. So I've provided you 30. So that would be equal to 5 times 10 to the power of negative 30, not 30. Alright, so as you can see, you just want to put this into perspective. So this will be equal to that. Or, to be more exact, 0.000a, where this has an amount of n0, sorry, will be equal to a times 10 to the power of negative n. Alright, cool. So now today we have learned scientific notation and the rest of law of integral indices along with what you've learned last time, alright? So let's do a final recap of what we've learned today. First, we've learned that a0 is equal to 0, forever 0, alright? Second thing we've learned is that a to the power of negative n is equal to a over an. That's the second thing we've learned. So, and the final thing we've learned about law of integral indices is a to the power of m divided by a to the power of n is equal to a to the power of m over n. So now we can move on to scientific notation, for which I'll just use this. First of all, the number must be between 1 and 10, and this must be 11 or 10. And this x has to be an integer. And then, for example, with a number, something like 11 million, for example, and we can express it as 1.1. And then count the zeros. We have 1, 2, 3, 4, 5, 6 zeros. So we times 6, 10 to the power of 6. Alright, cool? Thank you. So this is scientific notation for positive integers. And for negative, it will be 0.000a, for example. It would be equal to this amount of zeros. So for example, for that one would be 10 to the power of n, which would be the amount of zeros, times a. Alright? And if it's like ax right here, there's a number right here, that'll be times a point x. Alright? And well, it goes for the same if there's a y z back there. You just extend the number. Once again, I'd like to thank you for tuning in into today's lesson of maths. And I hope you have a great score in maths next time. Thank you.